Hello, it's Keith here, and this is day 6 of the Grime 68000 project. So how are things going? Well, I discussed yesterday that there was a few graphical glitches on some of the systems and I wasn't quite sure why it was. I've fixed that now. I've also looked at the Vblank problem where some of the systems were running faster than others. I'll go into that a little bit more later when we have a quick look at the code, but let's see the game in action now. So I think yesterday the animation actually wasn't in place. You can see now I've actually done that. All of the sprites now have 2 frames of animation, as with the 6502 systems. I mean, you know, obviously this isn't really much of a graphical game for 68000, but that was never the intention of this project. It was just to get the same game running on 6502, Z80 and 68000 systems, and so that's, you know, what we've done so far. So I think the gameplay is now complete, basically speaking. I don't think there's any limitations when compared to the Grime Z80. The only thing I do want to do now is, as I said yesterday, there's a bug in the code of Grime Z80 that I'm looking at. I don't know if it was fixed in the final version, but anyway, the version I'm copied this from, there's a bug where the Grime will expand off the right hand side of the screen onto the left hand side, which makes the game a bit harder than maybe it should be. So I want to try and fix that. So what I'm going to do is I'm going to have a look at the Grime 6502 code and make any changes that are required for that. And I'm also going to look at the X68000 version. As I said before, I want to try to make the tiles 8x10 rather than 8x8 as an option, just to see if that makes the game look a bit less squashed, which hopefully it will. So anyway, that's the Genesis version. Here's the Neo Geo version. So I've been working on the Vblank over the last sort of 24 hours, and now you can see that the Grime's expanding onto the other side of the screen there, which, as I say, it's not supposed to do. So that's, I'm going to try and fix that. The Vblank was a little bit tricky because it depends on detecting from the hardware when the screen has refreshed, and the way you do it is different on all of the systems. So the Genesis, you have to use the ports of the video display. It's basically the same as the sort of MSX and the Game Gear and that lot, but there's a bit you can test to see if it's in Vblank, so that's pretty straightforward. The Atari ST, I think that was fairly similar. The Amiga, I think, had a counter I had to check. I might have got that the wrong way around. The Neo Geo, actually, there's a that's not being filled there. I need to check that. There's actually on the Neo Geo there's a label in the header that points to the Vblank routine, so I just put a counter in there and then checked that counter. Just let me fix that bug before I forget it. Now the problem is I need to subtract 1 for my CLDIR command because the branch command works differently, but I'm actually automatically doing it as part of that CLDIR command, so that's why that happened there. So we'll fix that there. So yes, that was the Neo Geo. The really problematic one was the X68000. I couldn't figure out how to do it. The documentation I had on the display registers and things didn't really offer any explanation. The big problem with the 68000 is it's primarily a Japanese machine. There is a very good website that has some information on it, and I did have a look around that, but usually it answers the questions, but this time it didn't. I did see some documentation on someone trying to do some programming in C, which did give me some clues, and then I managed to do some research and figured it out. So what I ended up having to use was this Japanese document here. Now I can read Japanese, but it's slow, so I couldn't really read through this entire documentation to spot it. But basically there's this device called the MFP, which is multifunction peripheral or something like that. It's a sort of hardware device that looks quite innocent as part of the memory map, but what it's doing is it's actually checking for events on the system like power on and real-time clock alarms. And it also detects when the system has gone into vertical blank or into horizontal blank here. So you can test bit 5 of 8-bit memory address E8801 or 16-bit memory address E880. 88000, sorry, and you can then see if the system is in Vblank. So I'm waiting for it to go into Vblank and then come out of Vblank to check if the system has done a full page refresh, because if I was only checking if it went into Vblank or out of Vblank, then I would potentially have done 2 frames within a single tick. I will now show you the 68000 version as it stands. So you can see hopefully that the game is running at roughly the same speed. Now the text is still in the wrong position at the top of the screen, and that's because, as I've already said, my remaining task for the graphics is to try and extend the tiles and see how that looks and see if I prefer it. So yeah, that's coming. But as I say, the thing is, the 68000 had a wide variety of different processor speeds. Now changing the processor speed is only partially working. Now if I change it to 24 megahertz, it looks okay, the speed looks roughly the same, but if I change it to 100 megahertz, you'll see it's actually a lot faster. The reason for this is that basically it's now running at 60 FPS, whereas before it was probably running at 30. The actual logic code is now running in such a short amount of time that it's still managed to double the frame rate. So what I really need to do is count the number of Vblanks that have occurred, do all the logic code, and then wait until at least 2 have occurred or something like that to keep the game rate running at 30 frames a second. But to do that I need an interrupt handler, and I don't know how to write one for the 68000. So for this stage of game development on 68000 systems, I'm going to have to declare this as good enough. Obviously it's far from perfect, but as I say, this is only a simple project and it's my first real 68000 project, so I'm going to have to accept this as good enough. As I say though, my plans for the next 24 hours of programming is to try and make 8x10 tiles so that this uses all of the screen and it looks a little bit less squashed, because it looks okay, but I would like to see what the 8x10 tiles look like. Maybe I'll decide they don't look good enough, but I think it should only be an hour or two's coding, so you know there's enough time. So I'm going to do that. I'm going to, if I spot any of the bugs, I'm going to fix them. I'm going to work on that tile logic so that the Grime doesn't span over the right hand side of the screen and come onto the left hand side, because I really don't like that. And also I'm going to be doing code commenting along the way, and probably removing some of this Z80 remnant because it doesn't do anything. So yeah, that's what I'm basically planning to do over the next 24 hours. So as before, we're going to have a look at all of the different systems on the final day, but I don't think they're going to be much changed from what you've seen today or over the last day really. We're also going to do an 8th episode once the series has ended, which is going to go over all of the code and discuss how it all works. So yesterday there was that weird graphical glitch where tiles were appearing off the left hand side of the official tile map. So I did some looking at the code and I tried disabling various bits that would affect the tile map, and eventually I figured out, mainly from looking at the screen and noticing that the tiles would randomly appear, but they would only appear when a bullet was being hit. You could see it was very synchronized to the sound of the bullet hitting, so it was obviously something to do with the bullet striking, and eventually I identified it as being this code that was causing the problem. Now basically this pop BC here was, I think it was around here before, it was further up, and BC is holding the XY position of the tile to be updated. Now BC of course is not the true register, the registers are D1 to D7, but I'm using D1 and D4 as B and C to emulate my Z80 code, and one of those registers was being affected up here, and I guess it was being changed to 255 because essentially we were getting a tile offset of -1 when it came to drawing the tile here. So all I needed to do is move the pop BC from here to here and it was fixed. Unfortunately it took me a rather long amount of time to figure that out, but once I had figured it out it was pretty easy to fix. Now ironically I believe this basically the same problem happened on the 6502 version of Grime, but the visual appearance was very different. I was getting graphical corruption, half tiles were appearing and things, but as I say, it seems like it was actually the same problem, so maybe I should have found it a little bit faster. Okay, but just for a bit of extra interest for today's episode, let's have a look at the Vblank on all of the different systems. So this is the Neo Geo header file which I got off the internet, and you can see here there's a link to a Vblank command here, and that Vblank exists in what I've programmed into the footer. So here is the routine that's run during Vblank, and I've added this command to increment an 8-bit value called Vblank count. And that Vblank count is defined in the Grime 68000 code here as part of the user RAM. So it's automatically being incremented as part of the header, and then all I do in my wait Vblank is I read the Vblank count into D1, and then I keep checking it until it changes, and when it does, we return. Until it does, we keep kicking that watchdog just to keep the system alive, otherwise it will crash. So the Atari ST, I'm doing very similar. There's a built-in counter in the system at hexadecimal 462, so we read that in and wait until it changes. On the Genesis, we read in from VDP control, and I'm doing the same thing of waiting for Vblank to start and then waiting for it to end. So we're doing it both ways so that we make sure we've not managed to draw an entire flame within the Vblank timing, because that is a risk on some of these systems. So here's the Amiga version. We're checking memory address DF004. Obviously one of the bits there is doing the Vblank. I got this off the internet. I haven't actually looked at this memory address in the documentation yet to see how it works, but that seems to be working okay. And here's the X68000 version. We're using that port which I described here, and we're using bit 5 here, which detects the Vblank, as you can see here. I'm loading it in as a 16-bit value. It seems you can load it in as an 8-bit value, but it does work either way. And so there we go. So that's how we do the Vblank on all 5 systems. It's very different on all of the systems, which is unfortunately seems to be quite the nature of the beast on the 68000. The Z80 seem to be relatively consistent, but the 68000 seem to be very unpredictable in how they work. And part of that is, of course, the fact that you've got that running operating system on all of the machines, whereas with the Z80, the first thing we tend to do is disable interrupts and ignore the operating system altogether. But that just seems to be the way it is. Anyway, so the game is basically done with the exception of that bug with regards to the Grime expanding. And I need to do some cleaning up of the code, and I want to try and do that thing with the taller tiles on the 68000. But anyway, things are going very well. I hope you'll join me for tomorrow's final episode. Thanks for watching the series up until now. Thanks for watching and goodbye.